Hi everyone, this is Mrs. GA, and today we're going to learn about the sum and difference formulas. So the sum and difference formulas for sine, cosine, and tangent are all listed right here. I know it looks like a lot, but a few things to note. The sum and difference formulas for sine are really similar. For the sum, you're going to add these two expressions, and for the difference, it's the same expressions, but you're just subtracting. So these are really super similar. You just have to remember with the sum, you add, with the difference, you subtract. Same for cosine. The formulas are really similar. However, for the sum formula, you actually subtract, and for the difference formula, you add. And then for tangent, again, the sum and difference formulas are very similar. It's really just changing the signs accordingly. So for the sum formula, we add in the numerator and subtract in the denominator. For the difference, we subtract and add. So it's just flipped. Now, for the sine and cosine ones, at least, there's a little pattern or a little phrase that I say to help me remember. So whenever I'm doing these, in my head, I always say sine, cosine, cosine, sine, cosine, cosine, sine, sine. So you could say it a few times and it will kind of get stuck in your head, but it's sine, cosine, cosine, sine, cosine, cosine, sine, sine. So then all you need to remember from there is that for sine, the signs match. For cosine, the signs are opposite. Now for tangent, for the sum and difference here, you kind of just need to memorize them. It's really just adding the two in the top and then subtracting the product from one or adding the product to one. So again, once you have one memorized, the other is memorized. But again, for these two, the little phrase that I use, I recommend just saying it a few times: sine, cosine, cosine, sine, cosine, cosine, sine, sine. And it will help you memorize at least these four. Okay, so we use the sum and difference formulas to help us evaluate angles that we may not know exact values for. So for example, if I ask you to find the cosine of 75 degrees and you don't have a calculator, here 75 is not one of our unit circle angles. However, if there's a way that you can add or subtract angles that we know to make 75 degrees, then we can use a sum or difference formula to help us evaluate this expression without a calculator. So if I ask myself, what's a way I can add or subtract two angles I know to make 75, we could say, oh, well, that's just 45 plus 30. So this is a completely valid statement to make. These two are completely equal. So here I see, oh, well, since I know my sum formula for cosine, I can expand this out and I can evaluate. So remember, it's sine, cosine, cosine, sine, cosine, cosine, sine, sine. So for the cosine formula, again, it's cosine, cosine, sine, sine. And you have to remember, for cosine, the sum formula, we actually subtract. Now from here, it's just a matter of evaluating these, which we should have memorized. We should know that the cosine of 45 degrees is root 2 over 2. The cosine of 30 degrees is root 3 over 2. Sine of 45 is root 2 over 2. Sine of 30 is 1/2. So this will equal root 6 minus root 2 all over 4. And this is our exact answer. So again, the sum and difference formulas allow us to evaluate angles that we may not know using angles that we do know. Okay, now let's try this next one. Here we have the sine of pi over 12. So again, we have to come up with a way that we can add or subtract two angles that we know to get pi over 12. So I say, oh, okay, well, pi over 12 we can get by doing pi over 4 minus pi over 6. And if you need to on the side, you can kind of rewrite these with a different denominator. So we know that pi over 4 is 3 pi over 12, and then we know that pi over 6 is 2 pi over 12. So if we subtract these two, then it gives us 1 pi over 12. So here we're going to use a difference formula for sine. So remember, it goes sine, cosine, cosine, sine. So we do sine of pi over 4 cosine, and then cosine, and then sine. Sine, cosine, cosine, sine. And notice that the order here matches the order here. Remember, for sine, you can remember it because the sign matches. And now we just need to evaluate the individual expression. So sine of pi over 4, again, is root 2 over 2. Cosine of pi over 6, root 3 over 2, minus root 2 over 2, times 1/2. So here, we actually get the same exact answer. Okay, and for part C, again, tangent of 105 degrees, we need to come up with a way we can rewrite 105. So we can rewrite this as the tangent of 60 degrees plus 45 degrees. Again, these are both angles that are from the unit circle, so we should know how to evaluate any trig function with these angles. Okay, so now let's expand this out using our sum formula. So we do tangent of 60 plus tangent of 45 over 1 minus, and then we do the product of the two. Okay, so now we need to just evaluate the individual expressions. So the tangent of 60 degrees is root 3. Tangent of 45 is my favorite one because it's just equal to 1. And then we have 1 minus root 3 times 1. And so here, that just gives us root 3 plus 1 over 1 minus root 3. And this is fine. For these, you don't need to worry about rationalizing your denominator. We can leave our answer just like this. Do note, though, sometimes you end up with maybe a complex rational expression. In that case, you'll probably want to clear the complex rational expression by multiplying by the LCD. Okay, so at this time, I'm going to ask you to pause the video and give these three a try. Be careful here because you may be working with angles that are not in quadrant 1, so be careful with the sign of your different expressions. Okay, let's check here. So 7 pi over 12, we can rewrite by saying 3 pi over 4 minus pi over 6. This is just one way of doing it. So again, this is 9 pi over 4 minus 2 pi over, or 9 pi over 12 minus 2 pi over 12. And then we split it up. So remember, it's cosine, cosine, sine, sine. So again, here's our expanded form. We know the cosine of 3 pi over 4 is negative root 2 over 2. Cosine of pi over 6 is root 3 over 2. Sine of 3 pi over 4 is positive root 2 over 2. And sine of pi over 6 is 1/2. And then you just simplify below. For part B, you can rewrite 165 degrees as 120 degrees plus 45 degrees. So expand it as follows. Remember, sine, cosine, cosine, sine. Remember, the signs match. And then you just evaluate. So be careful here. Again, cosine is negative in quadrant 2. So just be careful that this is negative. And last, 13 pi over 12, you can rewrite that by saying 5 pi over 6 plus pi over 4. Remember, this is 10 pi over 12 plus 3 pi over 12, so 13 pi over 12. Again, expand it out and then simplify. So here is an example where you end up with a complex rational expression because tangent of 5 pi over 6 is negative root 3 over 3. So since we have this complex one, I would take that extra step of multiplying every single term in the numerator and denominator by 3. So this just becomes negative root 3, this becomes 3, this becomes 3, and this becomes positive root 3. So clear your tiny denominators by doing this last step, and then you can leave it like this for your final answer. Okay, so another use of these sum or difference formulas could be proving an identity or verifying an identity. So here we have that cofunction identity, which is the cosine of pi over 2 minus u equals the sine of u. So here I see that this is really just the difference formula. So we can expand it out. Remember, it's cosine, cosine, sine, sine. So cosine pi over 2 cosine u plus, remember it's opposite here, sine sine. And now we are going to evaluate. So the cosine of pi over 2, hopefully remember, is 0. Cosine of u, we just have to leave it alone because we can't evaluate that. The sine of pi over 2 is 1. Sine of u we leave alone. And if you simplify this, we're left with just the sine of u. So we've just verified the identity, and we use the difference formula to help us do that. Okay, here's the last example. Go ahead and pause the video and see if you can use the sum formula to help you verify this identity. Okay, let's check your work here. So again, we expand it out, and you get this expression, and then we know tangent of pi over 4 is 1. Tangent of x, we leave it alone, and so we end up with the left-hand side. So we are all set. All right, thank you so much for watching this video. I hope you have a great day.